Experience the new Simatic S7 1200 smart applications. This podcast shows you how simple it is to program step and servo motors with pulse interface in Step 7 Basic, using motion control blocks and the technological axis object. Chapter 1. Functional Principle of the Pulse Interface. Modular Simatic S7 1200 mini-controllers with their fast digital outputs are extremely suitable to control step and servo motors with a pulse interface. The controllers transfer a series of pulses together with a directional signal to the power unit of the drive. These signals are subsequently transposed into an axis movement by the power unit of the motor. Depending on the step or servo motor used, the axis moves by a defined angle with each pulse. As a result, the speed of the motor is determined by the number of pulses per second. The number of pulses with the largest possible dynamic of the drive is calculated from the maximum pulse frequency of the controller and the nominal speed of the motor. Chapter 2. Configuring the pulse interface. The pulse train for the drive is output through the pulse train output, short PTO. The PTO has been assigned a fixed output in the controller. The PTO is furthermore assigned to a high-speed counter that counts the output pulses. Two pulse generators are provided in the S7 1200 device configuration that can be configured for the use as PTO. Since CPUs with integrated relay outputs do not support the fast switching frequencies, you also have the option to use the additional pluggable signal boards with digital outputs. The assignment of the inputs and outputs for pulse, direction, and high-speed counter is automatic. Chapter 3. Technology Object Creating and Configuring an Axis. The generation of the pulse train is the responsibility of the Axis Technology Object. This technology object forms the interface between the user program and the drive in Step 7 Basic. When creating a new axis, a separate data block is automatically created for the technology object. The included axis parameters can be comfortably and easily configured using the provided editors. First of all, select the PTO for the axis control. Thus, you copy the configured pulse and direction output from the hardware configuration to the technology object. In the expanded set of parameters, you can, among other things, define interface signals such as, for example, the drive enable and the ready signal of the drive. For precise control of the motor, you have to furthermore ensure that the number of pulses per revolution is the same on the drive and the control side. To observe the position limits, you can configure the software and possibly existing hardware limit switches. You can also specify the dynamic of the drive in the axis configuration. The speed limits, acceleration, and emergency stop ramps are also part of the configuration. If you also want absolute positioning of the axis, then an assignment of a reference point switch is required. Chapter 4. Creating Motion Control Instructions. To control the motion sequences, you will require a user program. For this purpose, Step 7 Basic provides various motion control program blocks. The blocks pass on the jobs to the technology object. The technology object processes the individual jobs and sends the control signals to the drive through the PTO. The available blocks can be found in the extended instructions of the task card under Motion Control. The folder contains blocks for releasing and referencing the axis, relative and absolute positioning and moving of the axis, using speed specifications and jog mode. The blocks can simply be dragged in your project via drag and drop. As a result, you will be prompted to create the required instance data block. To create a connection to the axis technology object, you have to assign the axis input with the corresponding technology data block. Configure all the remaining inputs and outputs, and the first instruction is ready. With the provided motion control commands, you can quickly and easily achieve an efficient and structured user program. Chapter 5. Using the control board. Before testing the user program, it is recommended to check the general operability of the drive with the integrated control board. To take over the control, you have to change to manual control. The user program then has no influence on the functions of the axis anymore. After the subsequent release, you can move the axis in manual mode. For this purpose, you can select between the jogging, positioning, and referencing commands. Then enter the values for the position, speed, and acceleration. After the start of the axis, you can check the current values in the status display. The axis is now moved by the specified distance. After the end of the test, the control is given back to the controller through the automatic mode button. Chapter 6. Diagnostic functions. To monitor the proper operation of the axis, the technology object provides a diagnostic function with the most important status and error messages. This facilitates, for example, commissioning with the control board. This is how you can track changes in the operating status or the current position and speed values of the axis at all times. Pending monitoring and errors will also be displayed instantly. This particularly facilitates the initial commissioning of the drive. Chapter 7. Summary. Step 7 Basic provides you with an efficient engineering tool to program step and servo motors with pulse interface. It contains all required motion control blocks to create a powerful user program. The Axis Technology object provides you with the perfect interface for the drive. All essential properties of the axis can be quickly and easily configured with it. With the control board and the diagnostic functions, you are furthermore provided with the ideal tools for fast and secure initial commissioning. Additional information is provided on our website.